Okay, so we're going to do this problem as our first example. We have this non-homogeneous differential equation. So the homogeneous differential equation associated to this is y double prime plus 5y prime plus 6y equals 0. Now the characteristic equation to this is r squared plus 5r plus 6 equals 0, which factors into r plus 2, r plus 3 equals 0, which gives you that r equals minus 2 and r equals minus 3. So we have two solutions to this homogeneous system. One is e to the power of minus 2x, and the other one is e to the power of minus 3x. So we're going to call the solution to this homogeneous differential equation as yc. It's c1 e to the minus 2x plus c2 e to the minus 3x. Okay, we will save this solution when we'll come back and use it later. Next, what we will do is we will try to find one particular solution to this differential equation. Okay, and looking for a particular solution, if you focus on this right hand side, that right hand side is a quadratic function. And no, so what kind of function will give us a quadratic function when we multiply it by 6 and multiply the derivative by 5 and just this second derivative and add them up? What kind of function will give us a quadratic function? So the best guess we can come up with is y equals a quadratic function, which is ax squared plus bx plus c, in the form of ax squared plus bx plus c. And then we're going to find a, b, and c. So we're not looking for any other function that will give us a polynomial, because there's nothing that can give us a polynomial. Exponential functions or any of the transcendental functions, sine x, cos x, natural log of x, any of those, you try them, they'll never give us a polynomial. So the best case is the polynomial. And if we have a polynomial of degree higher than 2, then you will get that term by just multiplying it by 6. So best choice, sometimes we go into third degree, but that's dependent on what yc is. We'll have some examples on that. So we're going to try just y equals ax squared plus bx plus c. Take the derivative. This gives you 2ax plus b, and take the second derivative, it gives you 2a. Okay, so we will multiply the second derivative by, we check the second derivative, multiply the first derivative by 5, multiply the function by 6, and add them up, and we want it to equal this. Okay, so I have y double prime is 2a. Let's multiply y prime by 5. 5 times y prime gives us 10ax plus 5b. And let's multiply y by 6. So we're going to add these to give us that. Okay, so 6y is 6 times this expression, so it gives us 6ax squared plus 6bx plus 6c. Okay, we will add these. Okay, so that gives us y double prime plus 5 y prime plus 6y is now, so that's the only x squared term we have. No, sorry. So we're going to add this. So that's the only x squared term we get. So that gives us 6a x squared. And for the x term, these two are the only x terms that we get. So that will give us 6b plus 10a x. And the linear terms look like this. So this will give us 6c plus 5b plus 2a. So we want this to equal 6x squared, this guy here. Okay, I'm going to write this guy here. We want this to equal 6x squared plus 2x plus 1. All right, so this is one polynomial, a quadratic polynomial. This is one other polynomial, quadratic polynomial. They should equal for all x. When two polynomials are equal for all x, then the corresponding coefficients must be the same. So the coefficient for x squared is 6a. That should equal the coefficient for x squared on the right side. So that should equal 6. Let me use a different pen to highlight this. So the quotient for x squared, 6a, should equal the number 6. And this guy, 10a plus 6b, 10a plus 6b, what should that equal to? That should equal to 2. Okay? The third one is this guy, 2a plus 5b plus 6c. We want that to equal the constant term, 1. So we will solve this. Well, this is nice. I mean, we can find a and then b and then c in order. This gives us that a must be 1. We will save that. Okay, so we put 1 into a and solve for b. I'm just gonna shortcut this. So that's 10a. So 2 minus 10 is minus 8. So b is minus 8/6. This is minus 4/3. And then we're going to put that in here. We're going to put the a in here and then find c. So 2 times 1 minus 20/3. That's 2. 5b is minus 20/3 plus 6c. We want that to equal 1. So bringing everything to the right, that's minus 1 plus 20/3. 3 times 1 is 3. 20 minus 3 is 17/3. So c is 17/18. So our yc now looks like a x squared plus bx plus c is what our yp looks like, a particular solution. Okay, so we want yp, a particular solution to this differential equation, and we found one. Okay, therefore our solution is y equals c1 e to the minus 2x plus c2 e to the minus 3x plus 1x squared minus 4/3 x plus 17/3. So this is the solution to our differential equation up there. Okay, and this All right, I'm going to do one more example in the next page, and